So next we have freefall motion. Freefall motion is basically a continuation of uniform acceleration discussion in that the acceleration is constant at a non-zero value. Freefall motion, the object is restricted to move along the y-axis, along the vertical axis. And the only source of acceleration is gravity. The acceleration A is equal to the acceleration due to gravity, and it is constant at that value. The acceleration due to gravity varies from one location to another. For locations on or near the surface of the Earth, which will be the default situation as far as our discussion on freefall motion is concerned, for locations on or near the surface of the Earth, the acceleration due to gravity is given by A is equal to vector g, acceleration due to gravity. Vector g is equal to negative g. G is acceleration due to gravity magnitude, and g is just equal to 9.8 meters per second squared. So vector g is equal to negative g is equal to negative 9.8 meters per second squared. And it is constant at this value for as long as the object is on or near the surface of the Earth. Since the acceleration is constant, freefall motion is still basically uniform acceleration. As such, you have four equations that you can use to analyze the motion of the object as it undergoes freefall motion. V is equal to V naught plus GT. Y is equal to V naught T plus 1/2 GT squared. V squared is equal to V naught squared plus 2GY. V average is equal to V plus V naught over 2 is equal to delta Y divided by delta T. It's important to note that the acceleration is negative. It's because acceleration due to gravity, as far as this course is concerned, for now, for the time being, acceleration due to gravity is always heading towards the ground, is always heading towards negative y direction, so acceleration is negative. A is equal to negative 9.8 meters per second squared. Analyzing an object undergoing freefall motion is just like doing uniform acceleration analysis for any other system. Just consider that the object is restricted to move along the y-axis and that there is already a set value for the acceleration. Acceleration due to gravity. Consider now the following examples. First, we have sample problem 1. A pitcher on the ground tosses a baseball vertically upward with an initial speed of 12 meters per second. Letter A, how long does the ball take to reach its maximum height? Letter B, what is the velocity of the ball when it reaches a point 5 meters above the release point? And letter C, what is the velocity of the ball when the pitcher catches the ball? The pitcher tosses the baseball vertically upward. As such, the object will be undergoing free fall motion. automatically the acceleration is equal to negative 9.8 meters per second squared. The initial speed is 12 meters per second. The baseball is thrown vertically upward. Upward, that means the object is heading towards positive y. The initial velocity is positive 12 meters per second. And based on this information, you are asked for three things, letter A, B, and C. Starting with letter A, how long does the ball take to reach its maximum height? So how long does it take the ball to reach a particular position? So you are being asked for time of travel, T. At maximum height, note, the object is heading vertically upward, but the acceleration is negative. So acceleration is heading in the opposite direction. As the ball is moving upward, it is decelerating. It is slowing down. When it reaches maximum height, the velocity of the object has been reduced to 0. So final velocity upon reaching maximum height is equal to 0. This is uniform acceleration analysis basically. So you have four equations to choose from. One equation is V is equal to V naught plus GT. If you look at the known values, we know the final velocity V, V naught, and acceleration due to gravity. The only unknown is time of travel. The time it takes to reduce the velocity from 12 meters per second to 0, whereupon the object has reached the maximum height, so T is also time for maximum height. Isolating the variable T, we are able to calculate the time for maximum height, 1.224 seconds. Going now to letter B, velocity of the ball when it reaches 5 meters above the release point. So velocity at the 5-meter mark is being asked for. Let us set the displacement y to 5 meters. Such that if you now look at the equation, y is equal to v naught t plus 1/2 gt squared, and you transfer y to the other side and multiply the whole equation by 2, you have gt squared plus 2 v naught t minus 2y is equal to 0. We know g, we know v naught, and we know y. Plotting in those values, we get the following equation. Negative 9.8t squared plus 24t minus 10 is equal to 0. We have a quadratic equation. Solution to a quadratic equation rather, using your quadratic formula. Solution to a quadratic equation will give you two answers. You have T1 and T2. T1 is equal to 0.5324153,078 seconds. T2 is equal to 1.916564284 seconds. Both values of time are positive. That means both values of time are valid values, which tells us that the object will reach the 5-meter mark twice, on its way up and on its way down. So that means the answer for letter B you have two values. Velocity going up, it reaches the 5-meter mark. Velocity going down as it reaches the 5-meter mark. If we now look at V is equal to V naught plus GT equation, we know initial velocity, we know acceleration due to gravity G, and we have two values that we can use for time. The only unknown is final velocity. We are able to calculate the two values of the velocity. V1 for time t1, V1 is equal to 6.7823299984 meters per second. And for time t2, V2 is equal to negative 6.7823299984 meters per second. So, the velocity of the object as it reaches the 5-meter mark is V1 is equal to 6.782 meters per second and V2 is negative 6.782 meters per second. V1 is the velocity of the object as it goes up and reaches the 5-meter mark. And V2 is the velocity as the object is going down and reaches the 5-meter mark. If you compare the two, they are equal in value but opposite in direction. One is positive direction, the other one is negative direction. This illustrates one property of an object that has been thrown upward. The object passes through a given height or level twice on its way up and on its way down, and the velocities at that level are equal but opposite in direction. V down is equal to negative V up. Equal in magnitude as V up but opposite in direction. And this gives us the answer for part C. Part C, what is the velocity of the ball when the pitcher catches it? When the pitcher throws the ball upward, it has a velocity of 12 meters per second. When the pitcher catches the ball, so the ball goes back to the original position, it's now going down. V down is equal to negative V up. V catch is equal to negative 12 meters per second. Next, we have sample problem 2. A student, from the roof of a building, a student drops an egg. Several floors down, you have a window. A student at this window sees the egg pass by and determine the speed of the egg to be 25 meters per second. What is the distance between the window and the roof of the building? So, you have free fall motion. Automatically, the acceleration is acceleration due to gravity, negative 9.8 meters per second squared. The egg is simply dropped by the student. The initial velocity of the egg is 0. The object, the egg will fall down, traveling displacement y, traveling a distance of height h. Y is downward, so y is equal to negative h. Since the egg is traveling downwards at the window level, when the other student sees the egg pass by at 25 meters per second, the egg is heading downward, So the velocity is negative 25 meters per second. So in the figure, this should be negative 25 meters per second. Determine the distance h. So the egg is still undergoing uniform motion, free fall motion, uniform acceleration rather, not uniform motion, uniform acceleration, free fall motion. Once again, you have 4 equations to choose from to analyze the problem. One equation is v squared is equal to v naught squared plus 2gy. If you look at the known values, we know v, we know v naught, we know g. The only unknown is y. Y is negative h. We are looking for h. So isolate h and you are able to calculate the height h to be 31.888 meters. And that's it for now. That's it for our session, for this video rather. In the next video, we'll talk about projectile motion, the last part of our discussion on motion along a straight line or kinematics. So again, that's it for now. Thank you for watching.